To learn about volumes using known cross-sections, we're first just going to review area. To find the area between the curves f of x and g of x, you simply subtract f of x minus g of x to get that height. We know we integrate with using x here because first of all, as we go down, if we would continue to go down, we would hit the x-axis, and all of our slices are perpendicular to the x-axis. Additionally, everywhere we draw an arrow down or a height, every height you would see between A and B, f of x is on top and g of x is on bottom. So f of x doesn't cross over itself. Everywhere you go, a height is f of x from g of x. And remember, we go from top to bottom, f of x minus g of x, because that's how subtraction works. Larger numbers, you always say 4 minus 2. You're trying to find this positive area. Looking at our next shape, this shape is a little more complicated, especially if you try to integrate with respect to x. If you were to integrate with respect to x, you would get the height going straight down, parallel, perpendicular to the x-axis. If you notice, this is the same curve. It is more difficult to get the height in that manner. Instead, what we're going to do is we're going to go from f of y to g of y. We're going to take our heights here. So since we're going to go perpendicular to the y-axis, we're going to take everything off the y-axis. The c and the d, we're going to have y limits. Y equals c and y equals d. So everything is with respect to y. And if you notice, no matter how high up or low we go, we are always going from f of y to g of y to get those distances. So that's just a little review on area, because that's going to bring us to what we're doing next. So we were doing area, but now we're talking about volumes. So with volumes, we have 3 dimensions. 1, 2, 3. To find the volume of a cylinder, you first find the area of a circle, and then you multiply it by the height. And you can think of that like cutting this up into a bunch of circles. However, instead of this being a completely rounded shape like a cylinder, the base is going to be flat. So this would be where the base is. And then we are going to have cross sections. They could be semicircles, they could be squares, rectangles, triangles, to come up from the base. So as you see here in this example, this is one of the examples that we did in class. The base is actually this piece right here. And the semicircles are sections that are going up above that. So see how the semicircles are going up? We do not have this part of the shape. It is flat on the bottom. And we're going to find volume that way. So in order to find the volume, we're going to find the area of each semicircle. So that's different, because before we were finding area of this base shape. We were finding the area of this going from the top to the bottom, and we're getting the area of this shape. But now we're going to get the area of these semicircle cross sections, or squares, or triangles. So that's how it's different as far as what you're finding the area of. Yes, this base is the shape of something we used to find the area of, but now it is simply the base. And if we cut our cross sections perpendicular to the x-axis, we will integrate with respect to x. But if we cut our cross sections perpendicular to the y-axis, we'll integrate with respect to x. So these are the cross sections. On this one, we had our x-axis down here. It's not shown in the drawing. And we cut our cross sections perpendicular to the x-axis, and so this would be an x-axis. In class, we took the time to develop these formulas for finding the volume using known cross sections, and now I'm going to go over how to use the formulas. So if we have the region f of x equals x and g of x equals x squared, to find the area of this shaded area, we would go from 0 to 1, if you notice, you can go down, and everywhere f of x will touch g of x. So it would just be x minus x squared dx. So if you calculate this integral, it will give you the area of the gray shape. But that is not what we're doing anymore. Now, this gray shape, we don't want the area of that anymore. This becomes our new base. And we're going to use this base to grow a solid. So it's flat on the bottom and the base looks like this. And the first thing we're going to do is we're going to draw squares up from the base. So think of cutting a slice right here and taking your Play-Doh and building up a square top and then cutting it, so we're cutting out squares. And so we're still going from 0 to 1 like we did before. So to get the volume, we're still going from 0 to 1 because the cross sections are still going to go down and cut all the way from 0 to 1. We still are going to go f of x minus g of x because now this gives us the height. And for a square, if you see, the base and the height are the same. So here's the height that we need, which is going to be the base of the square, which is also the height. And so to get that length, it is just x minus x squared. And we square it because this is the base and this is the height, x minus x squared dx. So it's easier just to write x minus x squared squared. So that's where the squared comes from. So we're looking at, for volume, we need 3 dimensions. So this is the base, this is the height, and the dx is the width. And we're adding those up, adding these tiny little squares up from 0 to 1. But what if instead of squares, our cross sections were isosceles right triangles? So the base is still going to be the same. So here's the base. But now the equation is going to be a little different. And if you notice, we have the 1/2 that we developed, but also this is the formula of square cross sections, right? Notice that the formula for the isosceles right triangle cross sections says 1/2. And if you think about it, an isosceles right triangle is literally 1/2 of a square. And so your volume is going to be less by half. So the new volume equation is just going to be the same thing and have the half out in front of it. And this time I'm just going to write the x minus x squared dx. Same thing goes with the remaining formulas. All you need to do is add the coefficient. So an equilateral triangle has root 3 over 4 of the volume of a square. So that means the inside is all the same again. So for the semicircle, don't forget that the area of a circle is pi r squared. So a semicircle is going to be half of that. But in this case, f of x minus g of x, that is actually the diameter, not the radius. So to get the radius, we have to divide this by 2. And that's where our 8 comes in, because we're going to have a radius squared. So 2 squared is going to be 4, and 4 times this 2 that was already here gives us 8. So the pi over 8 is outside. We are still integrating from 0 to 1. And we are still x minus x squared dx. The only thing that would change this is if instead of having cross sections perpendicular to the x-axis, you could also be asked on this question to do cross sections perpendicular to the y-axis. Now, this would work on this shape as well, because if you start at the top, everywhere you go across, you're going to hit. The x squared curve goes first, and then to get these different heights for the base, the x squared curve then goes to the x curve. However, don't forget, you're integrating, you're perpendicular to the y-axis, and so you're integrating with respect to y. So instead of going dx, we're now with respect to y. So our volume with square cross sections would still go from 0 to 1 because this intersects on 1, but these are y equals. It's y equals 0 to y equals 1, and it's dy. So since this is dy and these are y's, we're not going to write x's inside here. We're not going to mix x's and y's. That just means we need to solve for y in both of these. So for the first one, for x, this is just y equals x. That's pretty easy. And for the second one, you have y equals x squared. You just take the square root, which gives you plus or minus square root of y equals x. But as you can notice, we're only using the positive part of the root y. Since we are going from the root y equation, with this being root y, to the x equals y equation, it now becomes root y minus y. And don't forget, that is just the base of the square. We still need the height of the square, so that is root y minus y times root minus y, or squared. And again, we're on the y-axis for our limits of integration, 0 to 1, and we have dy, and all of our equations are in y. Check, we're all in y. One more situation you may come across is rectangular cross sections. So the rectangular cross sections are going to be a little different. You can either have a constant height, which does not vary, and so you do not need like the base squared as in a square, or it can be a function of the base. So let's imagine that we had this shape and we have rectangular cross sections, and the height of the rectangle is 2. So it's a constant 2. So to find our volume, we need to still integrate between 0 and 1, and let's go dx. And we're going to need the base and the height. So we have the dx, so that's awesome. We just need the base. So the base is going to be the base of our shape again. So it is x minus x squared, and that is the length of our base, and the height is just 2. So all we have to do is multiply by 2. You can put the 2 in here, or since it's a constant, you can pull it out. Doesn't matter. If it's a function of the base, it could say something like 1/2 of the base, or 4 times the base. Let's say it said the rectangle's height equals 4 times the base. Right? In this case, remember, our base is going to be f of x minus g of x. So this time the volume is just going to be the same thing, integrated from 0 to 1. We're going to have the dx like normal, and the base, again, is going to be x minus x squared, and then our height is going to be 4 times the base. And again, this is the base. So you can either write it again, x minus x squared, or you can just square it. Either way you want to do it. I'm going to go ahead and write it again for you. And you can write it more simply because I'm sure you understand that, but sometimes it's good to see things. X minus x squared. So that's a little messy. Let me rewrite this. The volume equals, I'm going to pull that 4 out because I like my coefficients, my constants pulled out, especially if they're fractions. Gross, right? And inside, I'm just going to have x minus x squared. There are 2 of them, so I can do squared dx. And that's it. Have a great day.